Hello students, let's go to the next topic of our syllabus. That is nothing but what? Intensity distributions. Now here, before this lecture, we have learned how the interference pattern get occurred, and we have seen the geometrical method to determine the calculations or condition for constructive interference, maximum intensity point, condition for destructive interference, that is nothing but dark point. That conditions we have already derived. Then we have seen the relation between phase difference and path difference, and accordingly we have derived the conditions also. Now this point is nothing but what? The intensity distribution. Now intensity means what? As we know, suppose amplitude of the interfering wave is represented by A and intensity was represented by I. I is the intensity, A is the amplitude. Then we know that intensity is directly proportional to square of amplitude. So once you know the amplitude of the wave, take its square and it becomes what? Intensity. That we have to learn under this topic. So distribution of intensity of the wave. Let us suppose intensity of incident wave is I0. Intensity of incident wave is I0. For bright point, the intensity of the two wave having same amplitude, suppose they get interfere with each other, the resultant big pattern get created, that is said to be constructive interference, which has a amplitude equal to sum of these two. Suppose it is A, then it A for first wave, so it is A for first wave, A for second wave, resultant amplitude becomes twice A. After constructive interference, resultant pattern get increased, its intensity get added by these two, so the resultant amplitude is twice A. Now this twice A, if you take this as a resultant amplitude, its square comes here, it comes to be 4A square. Is it clear? 4A square, and intensity of incident wave is I0, it is A square, so we can write this directly proportional, we can write it as 4I0. So intensity of wave, maximum intensity of the interfering wave is 4I0, and minimum intensity would be definitely 0. A minus A, if we take, this is plus for constructive interference, for destructive interference it is A minus A, it comes to be 0. So intensity of interference pattern get distributed, and it varies from 4I0 and to 0, or we can say 0 to 4I0. That is the variation of intensity of interfering wave, varies from 0 to 4I0. When it becomes exactly 4I0, it is said to be constructive interference, bright point can be observed, and when it is 0, it is said to be destructive interference, we get here dark point. So that is nothing but what? Intensity distribution in terms of this amplitude and intensity relation we have seen. Now let's go further. They try to explain the same point in terms of what? In terms of superposition of wave principle. Now what exactly superposition of wave? We know two or more than two wave arrive at a point simultaneously, then the resultant displacement is sum of the displacement produced by these two or more wave independent of other, or they assume that no other wave is present, and their displacement, all of their displacement sum, it will give the resultant displacement. So for this, let us consider two sources we have seen in interference. Two sources are required, S1 and S2. The two waves coming from S1 and S2 are suppose represented by the equation E1 equal to and E2 equal to. These are nothing but a two wave coming from the two sources. S1 it is E1, S2 it is E2. We can write equation as E1 equal to E0 sine of omega t, and this as E0 sine of omega t plus phi. Now this phi is a phase difference between the two waves. Okay. Now these are the two waves represented by these two equations. Now when they interfere, resultant displacement according to principle of superposition of wave, resultant displacement of wave is what? It is sum of this displacement of these two waves. So we can write resultant displacement in terms of this E equal to E1 plus E2. This is E1, this is E2. Put it here. We can write E0 sine of omega t plus E0 sine of omega t plus phi. So this is resultant displacement. Now if you remember, in mathematics there is one formula for this: sine of A plus sine of C plus sine of D. 2 sine C plus D by 2 into cos C minus D by 2. So you can write the same equation. E0 is taken common. 2 sine, so 2 is taken, 2 sine of c plus d by 2. C is this, d is this. So c, this is d, c plus d by 2. Omega t plus omega t, twice omega t divided by 2 plus phi by 2. So this is the first part. Into cos c minus d by 2. C means omega t minus omega t plus phi, or this becomes again minus phi, and this divided by 2 we can say. Plus omega t minus omega t cancelled out. Cos of minus phi by 2 is cos phi by 2. So we can write this as 2 is 0. Take this term first. 2 is 0 cos of phi by 2. Some of you might have the problem that why it become minus here, why it become plus, because cos of minus theta is cos theta, into sine of 2 get cancelled out, omega t plus phi by 2. So this formula we get, this is nothing but what? This will give us a amplitude. So this will give us a amplitude of resultant motion, and this sine omega t plus phi by 2 is nothing but a simple equation. So here amplitude was given by twice e0 cos phi by 2. So that equation gives us a amplitude. If that gives us an amplitude, what should be the intensity? Intensity is square of amplitude. So what can we do? We can just write down this is amplitude. So intensity I equal to what? Or it is directly proportional to 2e0 cos of phi by 2 whole bracket square. And this would be the equation for intensity of interfering wave that we have calculated by principle of superposition of wave in terms of amplitude and the intensity that was related by this equation. Apart from this, again they have mentioned the next parameter they have mentioned in their book, that is nothing but what? If the two waves interfering with each other, they are coming to interfere, they have different intensities or amplitudes. Say suppose first is E10 and second is E20. In general E1 E2 just like the E10 E20 they have taken. In this situation, what would be the intensity is proportional to square of this two? Just add this to E10 plus E20 its square. Intensity is directly proportional to this, and here if it is intensity is directly proportional to this, but here what will occur? This directly proportional to this, it is maximum intensity for bright point, or we can say constructive interference. But in case of destructive interference, it becomes what? E10 minus E20 whole square. In this situation, as both of them have not a same amplitude, it is seen that the dark point is not perfectly dark. In this case, if both have same amplitude, a minus a, it comes to be 0. If they don't have same amplitude, it can't come to be 0. So dark point is not perfectly dark. Bright point is very bright, but dark point is not a perfectly dark. It should be observed a little bit bright. Why it observed a little bit bright? Because they have the different amplitude. So that they have mentioned. Apart from this, let's go to next topic of the syllabus. Condition for steady interference patterns. So what are the conditions for obtaining well-defined steady interference pattern? Conditions for well-defined steady interference pattern. So what are the conditions for well-defined interference pattern that we have to learn? Now here remember, steady means what? Well-defined steady interference pattern means what? We are able to visualize bright point and dark points separately. That type of interference pattern is said to be well-defined and steady. It is not moving. Points are not changing, not blinking. At some point it is bright, then it becomes dark. It is not blinking like this. So that is nothing but what? Steady interference pattern. It is not changing. It is steady, remains constant. Well-defined means what? We are able to identify bright and dark point together. So that type of interference pattern is said to be the well-defined steady interference pattern. Now we have to see some condition for this. Some of the condition already we have learned in previous points, just like that, but that we are going to repeat again. For that means all the condition must comes in same head. That's why these conditions, some of them conditions may get repeated. So let's start with the first. The two sources of light should be coherent. So this part already we have learned. Two sources must be coherent. So this condition already we have seen. The two sources of light must be coherent means what? Their frequency should not change, and whenever the frequency of the two waves coming from two sources of light, their frequency must be constant and the phase difference must be the same, or we can say phase difference must be the constant phase difference. Otherwise, it is not possible to get a well distinct steady interference pattern. So this is one of the first condition for this. Second condition, two sources of light must be monochromatic. The two sources of light must be monochromatic. That is second condition. We can write monochromatic. So the two sources of light must be monochromatic. What exactly monochromatic? Mono means single, chromatic means a wavelength. The two sources of light two sources of light or two waves coming from the two sources must have the same frequency, we can say. So sorry, same wavelength, we can say. And that is if the wavelength of the two sources must be same, light emitted by the two sources must be same wavelength, then the two sources are said to be monochromatic sources. If the two sources are not monochromatic, what get occurred, that we have to learn. It is common sense that we have just seen, if we change the wavelength, that means if we change the color of the light, that being visible reason, if we change the color, its wavelength get changes, and accordingly interfering effect get changes. So that it is very essential that the two sources must be monochromatic. So this is nothing but the second condition. Let's go to third condition. The two interfering wave must have same amplitude. Amplitude must be same. That is the third condition, amplitude. Why this condition get introduced here? Because if just we have seen must be same, as if there are constructive interference resultant amplitude A plus A, it is twice A, we get a bright point. But when there is a destructive interference A minus A, if both have same amplitude, it comes to be 0. So this is a dark point, this is a bright point. Perfectly bright, perfectly dark. That is possible only when the two waves coming from the two sources must have same amplitude. Apart from this, if suppose the first wave has an amplitude twice A and second has an amplitude A, twice A plus A, constructive interference, it comes to be thrice A. Definitely is bright point, and here the interference is constructive interference. And here when there is a destructive interference, or we can say dark point, what get occurred? Twice A minus A, it must come to be 0 for dark point. But twice A minus A, it is not 0, it comes to be A. That's the reason the two sources of light must have the same amplitude, otherwise dark point is not perfectly dark. That is the reason, or that's why this condition get introduced here for steady and well-defined interference pattern. Let's go to next. The separation between the two slits. Separation between the two slits must be small in comparison to slit and observing screen. Just if you remember, we have just seen the sources S1, S2 here like this. The one hole is here, S1, S2, and distance between them we have taken small d. This d must be very small as compared to distance from slit and the screen, that we have taken capital D. So this d must be very small as compared to capital D. This is the condition. If this condition is not satisfied, you can't get a well-defined interference pattern. So interference pattern get well-defined only if the two sources or distance between the two sources must be the same. That is, d must be very much smaller than capital D. That's why this that's why this condition get introduced here. Let's go to next. What will occur, and what will occur, the two slit should be the narrow. The next should be the two slits must be narrow. What does it mean? Narrow means as small as possible the two slits should be, and if the two slits are not narrow, what will occur? Suppose the sources, the S1 and S2, here it is S1, here it is S2. If this is very bigger, suppose they are very bigger, the light coming from them become like this, and the two sources, or this light, this point emit light here, this point emit light here, then see they will travel a little bit different distance. So this would be the difference, this much distance, this will travel longer than this, and that's why the two sources must be as narrow as possible, so that there should not be such type of path difference. Then it can't affect the interference pattern, or we get a steady interference pattern if the two sources, two slit must be the narrow. The last one, the two waves should be in same state of polarization. It's simple thing, the two waves, two sources in same state of polarization. Now this point is very important, but that is not related to here interference that much. So polarization, already this topic in this year they get skipped, but polarization means what? The vibration of light particle in certain unique direction. restriction to light vibration in certain direction, that is said to be polarization. If the two waves are moving like this, both of them are coming like this, they get interfere, that is said to be they are in the same state. If one wave, this is S1 coming like this, S2 comes like this. Suppose this is S1 is in this state of polarization, S2 is in this state of polarization. They combine together, then there is no interference. The interference get occurred when both the sources merge, means same state of vibration, most can vertical, combine and they travel like this. So that is the same state of vibration. So either vertical or horizontal, they are coming together, they get combined and they get move forward. So this is nothing but what? They are two sources of light merged in same state of polarization. Now let's go to the next part. Here we have learned the first condition, coherent source. How to obtain the coherent source, that we have to see now. To obtain the coherent source, there are two methods they have introduced. How to obtain a coherent source? Basically by the two experiment we can get the coherent sources. Now let's start with these two sources. What are the two methods to get these things, or to get a coherent light from coherent sources of light? What are the conditions that we have to learn here? So let's start with that conditions, and by the two experiment we can obtain here coherent source of light. What are the two experiments? So the first one is what? Lloyd's mirror. Lloyd's mirror is one of the method by which we can obtain the two sources of light which are coherent, okay, of the same wave frequency, and they are in phase or in a constant phase difference. So let's start with this. Lloyd's mirror is the first method to obtain a coherent source. Let's see how they will produce the two sources. So this is the screen we have taken, and here there is a real source of light. Apart this one is a blue one, a blue and black combined together, real source of light. And this square I have put it here down. This I have shown by some lines here. What inclined line? That is a reflecting surface, plain reflecting surface. Now what get occurred in this? Some light ray coming from this. Suppose we have taken this is black color. So black color light rays are coming from real sources, and directly we get it here on this on the screen. This point directly one wave come, second wave come, third wave come. That was represented by black color. Directly they are coming from the real source on the screen. Apart from this, the blue color three waves I have shown here. This is blue color three waves. What will occur? They will incident on reflecting surface. Just try with this. Incident on reflecting surface. It get reflected, then come to the screen. Second wave, again incident on the reflecting surface, reflected and come it here. Third also, incident on reflecting surface, then come it here. So what get occurred here? The two light sources get created, and one is said to be real one, that is the actual source. Other is said to be virtual one, because actually does not exist. It was created for sake of understanding. So to make it two sources of light, this was created. Now that was created by reflection. So see, whatever the reflecting waves instead on this, just elongate it backward here like this, elongate it backward. We get here the second virtual source, that is said to be virtual source. Actually does not exist. So this one and this real one, these two act as a two sources of light for interference pattern. One is said to be real source of light, other is said to be virtual source of light. So this is a method that is said to be Lloyd's mirror method to create a two sources of light. Let's go to second method, that is nothing but what? By using Fresnel Biprism. So this is the second method, by using Fresnel Biprism. What exactly this method is? In this method they will use a Fresnel Biprism. As its name suggests that it is biprism, two prism connected back to back, joining their bases. It will create a new geometric diagram or geometric device that is said to be biprism. Biprism has a refracting angle, refracting edges having an angle greater than 180 degrees. So it is approximately 180. If we just take this further, this angle is must be approximately 180 degree, and refracting edges, this at the bottom, this one and this one, this might be of the order of 30 minutes to 1 degree. Then what will occur? The singles, this is a slit and this is single source of light. It will emit a light in upward and backward downward direction on the biprism. What will occur? Biprism refract the light. It will refract on the screen. Then after that, if you see this inner wave refracted on the screen, and I have shown this is a shaded region. That shaded region is nothing but what? Region where the two waves, one coming from upper part another coming from downward part. They combine together, interfere together, superimpose together, and they will produce a interference pattern. Remember, this is the region where there is superposition of wave, shaded part, superposition of wave, or we can say interference of the light waves coming from the upper and downward part of biprism. Now let's go. Elongate the same waves in backward direction. What we get here, this point we get at the bottom, it is suppose S2. Similarly, elongate it upward, it is suppose S1. The distance between them is small d. Then these 2 points act S1 and S2 act as a 2 sources of light. Again remember, these are not real sources of light, really single source. So these are the virtual sources of light, and we can say that this interference pattern can be obtained by these 2 virtual sources S1 and S2, and this is said to be biprism experiment, Fresnel biprism experiment, to give a 2 virtual sources for interference of light. So in this fashion, either by lioyds mirror or by Fresnel biprism, we can obtain the 2 coherent sources of light. Now here further the next point is optical path. I think it is better to stop it now. Now in next period we will start with this word optical path, and then we will start with the diffraction of light. At most two periods are required, or single period are not a 2. Within a single period we will finish this chapter, because the next remaining topic of the same chapter that was skipped this year. Okay, so one video is required, that might be of 20 to 30 minutes video. So students, try to understand my video first, try to watch my video, try to understand the concept. Once you get it, read the same topic from your book. I am sure that you get a better understanding of the same concept. So take care, and let's see in the next video. Thank you.